So hi guys, just let's wait for like 2 minutes and then we will start with the presentation.
Hi, Kunal. Hi, everyone.
Hi Simran, hi. Hi everyone.
Yeah.
Hello, everybody.
Kunal, you ready? Your
Yes,
presentation?
I'm ready.
Okay,
Yeah,
yeah.
yeah. I think I should start. Enough people
Okay.
have joined, so this is good. Let me start. So basically, uh, just give me a sec. Okay. So today I'm going to show you something that feels like magic, and then I'm going to break it. So let's start.
I
Yes.
love magic.
Yeah. So imagine asking your database a question in plain English and getting the answer. No SQL knowledge needed. No more waiting for the data team. Just ask and receive. This is the promise of text to SQL. And the magic is that you can do it only just in 10 lines of code. That is the magic. That is the crazy part. So look, as you can see, we are just importing this OpenAI, and then we have some responses. We are actually sending the schema, sending the question, and get the SQL back. That's it. So let me prove it to you. But first, like a little bit of talk about like what database we are using. So we are going to use database for an RFP system. So let me explain the database. You don't need to memorize it, just food for thought. So the flow is like RFP is request for proposal. It's a bidding and a tender system. So basically buyer creates RFPs that I need a CRM system, etc., with their budget and all. And then supplier respond to it. Like, like as you can see, like A, B, C, D. And then buyers actually reviews and award one supplier as a winner. And that's it. That is how it is done. So so don't memorize this, but the point is that it is a complex enough to be realistic. We have 11 tables: users, role, RFPs, versioning, responses, documents, audit trails. So that is we have. So this is basically a visual real relationships, real foreign keys. Now so as you can see, users, we have users, RFPs, responses, and we are doing some kind of versioning with the RFPs, and then we are also storing it in a document. Like we have a separate table to store our documents, separate table to store our status for both RFPs and so I think that is enough. Don't memorize, just a little bit of refreshing. So now like let me switch back to the terminal and show you how it will perform for 10 lines of code. So this is the only the code I have written for it. As you can see, we are using Cloud 3.5 IQ version. This is the context we are sending to the LLM. only this much, the schema sent to the LLM. We are just, giving them tables and all. That is it, RFPs, etc., etc. No description, no example, just table and that is all, with table names and columns. That is it. For let's start with the first query. So the first query I did was show all users. So it is a very simple query, and LLM handles it quite well. It just it is generated in real time. The thing that you are seeing in that select star from users, and then we are showing the query result here. That is, it returned 10 rows. Actually, I've truncated it to just show 5 rows because like it is easy to show it in the demo. But yeah, actually it returns 10, and this is the real-time generated SQL. Let's go for the second query. So in the second query also, as you can see, list all RFPs and their titles. I mean, it is very easy, right? Like select star title, ID title from RFPs, and that's it. That is how you get it. And it returns 7 rows. So just to remind you guys, so these are the queries that are actually, these are the SQL queries that are actually given to us by the LLM, like in the real time. It is happening. I have basically set up the code in a way that it is easier to see it in the terminal. But these are the real queries that are happening by calling the LLM directly. So the next query is count the number of rows, count the number of users, and it is simple. Next is show all the roles in the system. Great. I think we have 3 roles only: admin, buyer, and supplier. That is good for us. Fifth one is list RFP status. Select ID, code, label, etc. for RFP and buy details, and it is superb actually. So as you can see, with just 10 lines of code, no simple queries work well. No training required. Feels like magic, right? So are we done? Should we ship it to the production? Well, not quite. So let me show you. But the same code will not work with the slightly harder questions. That is the point, right? It will not work with the slightly harder questions. So the same code, same schema, slightly harder question, but I think it will fail. Like I'm sure, I'm sure of it. But let's just go for it. As you can see, same code, these 10 lines of code, same context we are providing, basically the same information we are providing to the LLM, the same schema and the tables and all. The only difference is harder questions. That is the only difference. So the first question is show all published RFPs. So it is generating an SQL. So this is the SQL it is generated. Now let me execute this SQL. As you can see, yeah, Kaushik, you have any questions? Hello,
Sorry,
Kaushik, you are
didn't
on
mean
mute.
to interrupt. Yeah, sorry, I was speaking to me. So I didn't mean to interrupt, but because you stopped, uh, why this question is harder compared to the
Yeah,
previous?
that is
All published
the question
RFP. Yeah.
I'm trying to give an answer to. Just wait for a second, right? So as you
Sure.
can see, like these are the tough ones because just told him that show all the published RFPs, and it is basically, if the failure type of it is a silent failure. Why? Because as you can see, it returned 0 rows, but that is not the case. We actually have some published RFPs into our system, but why it is happening? It is happening because of this. That the status code is in actually lowercase published, and the LLM generated published, which is in uppercase, and it is happening in the real time. It is not that this is basically that I've had. Actually, this is what happened. So as you can see, these are really dangerous things. Why? Because like they are giving you correct results, and you may think that okay, this one looks fine, no rows. Okay, maybe we don't have any RFPs that are published, but that is not the case. Yeah, Kosh, go ahead.
Yeah, so yeah, I get it. This is still to me doable, but my like I might have missed if your previous question was that show me the statuses of RFPs, right? So that time the query did not have any joins. So now why so much joins? That's what I'm wondering.
Okay, so the query is this: show all published RFPs.
Right.
So to show the all the published
So
RFPs,
what is your expectation? Let me pause you here. Sorry. So when you say show me the RFP statuses, what is your expectation? You are okay to see the RFP ID and the statuses, right? In the previous page.
in the previous page, yes, but this now the query is that we have RFPs that we have to
Yeah,
show that are
sorry. Just a second. In the previous page, you said show me the RFPs. Sorry, all the statuses of RFPs. There you are okay
yeah
to see RFP
yeah
code and the statuses, correct? So
yes
now if you're asking show me the published RFPs, the
yeah
expectation should be code and the level are all published. That is
yeah
first thing I want to agree with you. Do you agree with that or not?
yes.
So now why user join happening here?
So the user join happening here is because to okay. So this is not actually generated by me. So this is
I
generated
know,
by
but to me is
yeah.
that
Let
how
me
it
just
thought that user join is needed. That is what I'm getting. And like the output also has code and level. So even the role of user join, I did not get. You know what
role
I'm
of user
saying?
join.
This is food
Yeah
for your thought. I know you are not generating all these things, but just I
yeah.
want to point out, right?
Okay, yeah. That is correct though. So maybe
And
that
and
this
put
this
another way,
line might also be
yeah,
incorrect as well. But like
sure.
but the point of this is that even with if this line might not be there or not, it is actually going for the published status that is in the uppercase. And still, if everything is correct, still it will show you the silent failure just because that we have a status code in lowercase in our database.
So yeah, so this point is well taken. My silent point is like more than the users. Two questions: show me all the statuses in the RFPs and show me the published RFPs. To me, of same difficulty level as far as me as a user is concerned.
Yeah,
I think somehow you getting motivated by the output, and because the output fails, you are putting this question as a default category, sorry, difficult category, and the previous question as simpler category.
yeah.
But
So the
you know what I'm saying? Why
it
this?
is this yeah. So
Yeah.
why I have put it in the difficult category is because only this point that in my database, specifically in my database, I have lower case uh like the status, not uppercase. Like usually we do have uppercase, but in this we have lowercase database. Like so, it is getting this RFP status dot code is equal to my published. As you can see, it is uppercase, but but to my point is that we actually have lowercase like published version, not the uppercase published version. So that is why the query is difficult for the LLM because it doesn't have the context that my LLM, like my database, have the lowercase status RFPs. That is why I have put it in the difficult category. Like, and it is also harder because like like you
Can you
might not
type?
think about it.
Can you type so all published with P capital? Let's see,
Sorry.
because then the exact value matches, right? So your labels are actually P capitalized, others are small, right?
Yeah. So
Sorry,
sorry.
I mean we can do that later. You can complete your plan and then you can do it later. I don't
Yeah,
mean
I
to
think
like
yeah.
interrupt your thoughts. Yeah.
So basically this is the query fails just because of the status RFPs also, that it is saying published in the uppercase, but we actually have the lowercase status in our like database, and we have not provided this context to the LLM. So let me go to the second query. Why it is bad? Because no error, no published, as you can see, but there are actually 3 published ones in our database. So the next query that we are going to check is RFPs closing this week. Sorry. So
Like
this
it.
is the generated SQL select from joins, some kind of join it is happening. Let me check. So it is showing the error like this generated SQL is not correct. Why it is not correct? Because deadline is the problem. Like in the RFP versions table, not RFP table. Deadline is actually in the RFP version table. As you can see, deadline is in the RFP versioning table, not in the RFPs. And the LLM is querying the RFPs, like RFP table for it. So that is it is bad because imagine that this might happen in our production, right? So the third query is show me sales. LLM has generated some kind of query. Let me run it. So it has shows us some kind of data, but the verdict here is that it is hallucinated. Why? Because there is no sale concept in this database, and it returns data and it is not sale, but it is something that it made up. So think that maybe this is what we say when we say like show me sales. So this is actually dangerous for us. Yeah, Kushal.
Okay, so we are asking the LLM to generate an SQL query, and then we are executing that query. Are we going back to the LLM?
No. For executing it just the code part. We are just generating the query using the LLM.
Okay. So after
Yeah.
generating the query, I mean, these values don't exist, right? These titles don't exist in the database, right?
These exist, but the point is that we don't have any concept of sales in the database. In the
Okay.
RFP world, we don't have any like sales concept. Like
Okay,
it
so this
is
was a
quite
valid
different.
query, but it was not semantically relevant.
Yeah. Like
Okay.
and even like it is hallucinating because like LLM should have asked us like what do you mean by sales? Like if it doesn't
Exactly.
know actually what is happening, it should have said that.
Hmm.
Yes,
Okay,
Kaushik.
makes sense.
Yeah, so sorry, I lost track. I was listening to, yes. So one is that when you're getting this response, is there any way we can get a confidence score on the SQL, on the
Yeah, we can
output?
do it, but yeah, like that is for the later part actually. Let me just there are so many slides I have to show. So
Sure. I mean, but you were saying that later part you will display the confidence score. My question is that based on confidence score, so couple of 2 points, right? You said that it should have asked about what is sales. Most
yeah,
likely, the text to SQL will not do that. It will just return a response SQL with a score. The job of asking that
I think yeah,
should
you
be
are
given
right,
earlier,
Kaushik.
right?
But the question is that you are jumping ahead actually. I
Okay.
have actually tackled these things in my slide. So just hold for a second. Just I have Q&A section as well. So after the talk, we can have taken that questions, right? So let me just
Sure.
complete this and
Sure.
then we can
I'll
talk about
wait.
whatever is wrong, what is right in this, right? So next is show me all the active RFPs. So this is the query, and the failure type is ambiguity. So this is the query that is generated by LLM, and it show rows return is equal to me 0. Why this is wrong? Because like we don't mean like we don't know what active means, right? Published, not closed, not deleted. We don't have provided that context to the LLM. Like what do we mean by active when we are saying that show me all the active RFPs? So that is why it is wrong. And LLM actually guesses something here and there, like like here it should mean like it has open and in progress, something like this. So we don't have it, but it is just totally based on its guess. So as you can see in this, I have tried to show you 4 types of failures: silent failures, schema error, hallucinations, and ambiguity. The problem isn't that it is, it is wrong 50% of the time. Problem is that you don't know which 50% it is wrong. Like as you can see in the previous, all the queries run that are very simple, and in this, like 50%, like most like every query fails, like because there are some slighter, harder, or maybe like some kind of ambiguous and some kind of hallucination happening in here and there. So that is for this. As I shown you, these are the 4 kind of failures. So this is the benchmark reality for now. Like even for the best models, like even for the GPT-5, as you can see, it only gets 31% on the real enterprise queries. It only gets 31% correct, right? And the and as you can see in the Spider 1.0, that is academic, it is showing accuracy 91%. Like, but this is not the real world benchmark, right? The real world benchmark is that when you run it on a actual enterprise database, like even my database is not that of much of complex, but it is complex and enough to, so that LLM hallucinates on it. LLM have to think about it. We have to provide more context to the LLM. So that is the benchmark reality. Now let's climb to the 80%. That is the part where we will start. So right now we have just, does this part like row LLM plus schema. We have provided the schema to the LLM. That's it. And we are just, asking queries to it with like 10 lines of code. So for this, actually, I have some things. So the first impression, like you can add description to your schemas, right? It costs $0, and the time is actually, subjective. It could be 30 minutes, it could be 60. Don't know, but it will actually give you some kind of gains. Like before we can say that user's ID, name, email, role ID, status, and after with some context, we can say that we can give him like actual information about the schema with the actual descriptions. So let me show you this part. So this is Python. So the code is unchanged. We have not changed the code. This is the 10 lines we are still using. Before we were using this schema, like there's no description. We have provided this much context to our LLM. But now we are providing this much of context. We are enhancing the schema with the description. We are enhancing the schema with some kind of business rules. We are also saying that an active RFP has status published, not deleted is null, and some kind of business rules we are trying to give it to the uh, LLM, so that it generates good queries. So the first query is show me all active RFPs. So as you can see, without schema description, like without this context, it has generated this SQL, which returned actually 0 rows, but that is not the case. And with schema description, it has written a valid scheme, like valid SQL query and it has written us the 3 rows for it, because in the schema description we have provided the context that then active RFP has status published and deleted at is none. That is what actually it is doing in this, right? So this is the first query. Let's go to the second query. Show RFPs with their current budget. So this is little bit tricky. Just, spare with me. So without schema description, it generated this query, just LLM, this SQL query, and it actually returns some results. So it returns us 7 rows. So with their current budget and all. But the issue is this, that it is returning 7 and it is returning 6. And this is the correct one. Why? Well, the answer is this, deleted at. So basically, we obviously, like, if a real user is querying this, that show me RFPs with their current budget, we are absolutely not going to show them the deleted ones as well, right? We are also going to show them that those are the active ones, because that is the like hidden thing, right? Like we have to only show that those which are not soft deleted, those which are actually active with their current budget. So even though these two schema, like these two SQL looks correct, but this one is right because it is not giving you the deleted one as well. As you can see, it is providing you 7 rows and it is providing you 6, and the one less row is the one that is actually deleted, like soft deleted, not hard delete, but soft deleted, and it is showing that as well in the first schema description. Third query. So without guest, open doesn't exist. With understood, open for responses means published and deadline not passed. So basically what I'm trying to say here is that I said it to the SQL, like to the LLM, show error RFPs that are still open for responses. So if if someone forgets about what is RFP, let me just remind them again. So RFP is a request for proposal system where we have buyers and suppliers. Buyers post that they need something and supplier respond to them, and then buyer actually receive those responses and reward one of them the RFPs. So the query is that show RFP that are still open for responses. So basically we are trying to get the RFPs that are published but still not awarded anything. So in the first, it actually guesses that the status might have been open, right? Like it doesn't know, like even like give me like let me give you. So with this schema only, it doesn't know that do we what kind of status we have for the RFPs, right? But with this, we have actually told it, right? Draft, published, closed, awarded, cancelled, and we have also shown the life cycle. Draft, published, closed, awarded, or cancelled at any point, right? So because of this context, it knows that when we are saying that RFP are still open for responses, we are actually saying that, okay, show me the ones that are published. So that this is the key difference here, is that it knows it is published and the deadline is not exceeded. Obviously, like 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 in the RFPs, you have to give a deadline, right? You can't say that like every buyer wants to have a response in a certain timeline, right? You can say like the supplier has the time to respond in like 3 months, 1 month, 3 weeks. That is all. But after that, they have to take a decision, right? You can't say like it is open for like every time. So that is why the context is here that it is asking for the published ones that are not deleted and that are actually deadline has not passed. So as you can see that with the correct context, we can do good things, right? Second is this. I asked the LLM, show me the total proposed budget across submitted responses, right? Total proposed budget across all submitted responses. It tried to do some kind of sum with proposed budget at total proposed budget, some kind of it. And it actually give us none. But here, this is the correct query. Why? Because it is using submitted, which is lowercase, not the uppercase, right? The issue with the uppercase, it is has uppercase, it is lowercase submitted. So that is the issue. And because we have provided the context that in our database, we are using lowercase, like we have actually have lowercase status. That is why this time it is giving us the correct answer. Apart from like previous one also, that even like Kushik was mentioning that the published and published, right? So in that query, we have published that was uppercase, and that query was failing because the published was the up is right is written in the uppercase. But actually, we have to use the lowercase, and we have provided this context to the LLM right now. Last query, show me the best performing suppliers. Okay, it has done something. It has done something. Okay. So it has, without schema description, it has also given some kind of SQL generation and with a schema description as well. But the issue is that without it randomly guesses what best means. It doesn't know like what best means. I'm just showing that I'm just giving, I'm just asking it, show me the best performing suppliers. And it doesn't have the context what best means actually. And and even with the schema description, it still guesses because schema also doesn't describe the best performing. So the lesson here is the schema description helps with known terms, but can't solve ambiguity. Like, like we can provide the schema, but still, if someone is going to ask, like, show me the best performing suppliers, and this is actually the like this query can actually happen. And with the schema description also, we will fail, and we will fail because like schema description, like we can't solve ambiguity, right? That is it. So second layer is few short examples. So the second improvement is that we are going to show it some kind of examples, and obviously it costs $0, and the time is also relative, like and it also give you some kind of better results than we were expecting as before. So let me write it. So in this, as you can see, this is before and this is after. The example added to every prompt. So we are adding these examples to it, right? Example one, show all our active RFPs, current budget, count RFP per, like some of the generic ones that we know that user might ask, right? So we have added these ones. The model, and yeah, this is the best part. We are using the same model, like Claude 3.5, so on, like 3.5 Haiku. And even with that, the query is actually resolving because we are providing better context. We are providing schema descriptions. Now we are providing examples here. So that actually, help the LLM to get the correct results. Like you don't have to use like Opus 4.5 to get the correct result. Even with that, it will fails. Why it will fails? Because like uh, because it doesn't have the correct context. Yes, Kushagra, you have something to ask.
Yeah, I was just asking about these example queries. Again, we don't have an example of the best, right? So that is still an ambiguity in the mind of the LLM, right?
Yeah. I have not given the example of the best here as well, right? It just on the purpose, right?
Okay.
So,
Okay.
but the query I'm going to ask him is not going to be the best one, right? Right? Like I should have given an example of the best one, but right now I just don't give it. So I just miss it actually. So so but now let me give you this one. Like the first query is this: show me RFPs closing next month. So it is doing some kind of, and the row return is 0. And with few short examples, it is actually given us the correct ones. Why? Because without this example, it guesses the date logic. And with it actually gives the date range patterns from examples. Like we have provided him some kind of examples regarding the date, right? Exactly here. RFP closed this week. We have provided that you have to query that and like the database like this. Second query is which supplier has won the most RFPs? This is without few short examples. This is with few short examples. The key difference is like it doesn't know how to count wins, right? But here we have provided the example that shows supplier with their win rate, and we are giving him like some kind of context that how you can query that, and then it generated the SQL. Like and like as you can see, the key difference is that without it may not know how the count wins, but with it actually uses the win rate pattern. Like status is equal to my awarded. That is the win rate pattern, right? So this is for this. Third query: show RFPs with budget over $1,000. So with few short examples, it gives us 3, and without few short examples, it gives us 3 rows, and with few short examples, it gives us 6 actually. And why? Like without it may not know you have to join the RFP version for budget. Like let me show you if this is not clear. For the budget part, this is the budget, and we are showing budget in the RFP version table, not in the RFP itself. So it is trying to query the budget, but through RV, and RV means like that is RFP. So like even with the RV versioning, it is giving us the wrong answer somehow because it doesn't have the full context on this. Next is count how many responses each supplier has submitted. So key difference here that it actually, it is giving us 5 queries and it is giving us six queries because like this is ambiguous, right? The the above ones, without few short examples, we are generating the SQL, but we don't know if it is correct or not, right? Like it could be correct sometimes, it could be incorrect. Like it could give us some kind of, like even with this, it actually gives us 5 and it actually gives us 6. So one is actually still missing, but still we don't know that if the SQL is giving the answer is correct or not. We have to manually check it. And that is the main issue with this. Like sometimes, as you can see, even with this example, it is trying to give us some kind of, some kind of like good return. Like it just give us like 3 rows in this. It gives us six rows. But how do we know like which one is correct, right? That is the main point to it. Like sometimes like because they are not hard coded and the LLM is generating these SQL on the fly, sometimes it might be correct, sometimes it might be incorrect. And with all of my example, it is incorrect because I have chosen those examples just to show you that, okay, LLM is incorrect in these of the examples. Okay, so last query is show active RFP with no responses yet. So this one is showing return 0. This one also showing return 0. And combine active definition. Right now it guesses that published means like active. So right here, as you can see, is in this somehow giving me the exact correct one. But I don't know, like I can't have it make it guess. Okay, you know, okay, so I can't rely on, basically that is my point, right? You can't rely on it like fully. The sixth query is the harder one. Show me high value RFPs that need attention. Okay, so just give me a second. I think. Yeah, somebody can please check the like our monitoring channel. I think there is some like there is some like some
Kunal,
kind
you
of.
can continue with it. It's fine.
Okay,
We
okay,
can check
sure.
it. Yeah.
Okay, sure, great. So this is the last example that I'm showing it. Here I was querying, show me the high value RFPs that need attention. Both of them give us some results. It is giving us that row returns 3, row returns 0. But the issue is here, example teaches pattern, but still can't solve ambiguity. Like even with this, we don't know that if this is correct, if this is not correct. Because like this query we are trying to get from the LLM is ambiguous. We are saying, show me high value RFPs that need attention. What do we mean by high value? That is the main point here. That is the main issue here. We don't know it, and that is ambiguous. And still, it is generating some kind of query for us. But we don't know if this is correct or not. So that is it. And here we are we now. Like still one in every 4 query is wrong, and we don't know which one could be wrong. Like somehow, like if the user might ask, like for me, it could be like 100% right every time. And for somebody else, it could give us 100% wrong answers because it is still have that 25% bandwidth of giving the wrong examples, even with schema description and giving the few short examples to it. As exactly that what I was trying to say, like the 25% problem. The 75% accuracy looks good, but you don't know which 25% is wrong. Failure clusters on complex queries, the one that actually matters most. And there's some kind of silent failures as well. Now the SQL is giving them some kind of result, and we don't know if this is correct or not. And if the user have to go and check every time if the LLM generated answer is correct or not, then it defeats the whole purpose. That is my point. Now, getting to the 80%, the agent pattern, right? I think we are trying to, have it even in our in our like in our product as well, that if that never confidently wrong, either right or ask for help. So I think it will basically try to there, like this is an agent. First it will, that the question that you're going to ask it will ask that if this is clarified or not, and if it is not, then it is asked for the clarifications. Like if the if the question that you're trying to give to the LLM and that is ambiguous, then it is still going to ask for the clarifications. That is the part where, I think like what she was saying earlier, right? That like for the text to SQL, it doesn't, it is not is tough to, solve the ambiguity. It is the part of the agent as well. So this is simple agent. I'm trying to show you the clarification agent. It is very simple. So this is the agent flow, some kind of patterns. And if it is ambiguous, yes, ask for clarification. No, then generate the SQL. And this is happening again and again. Still, still every like clarification is handled or not. So the key insight is that one extra LLM code will be generated and it will detect some kind of ambiguity. First is show me all active RFPs. So step one, interpretation, right? So basically what is happening is that user has asked to see the RFP that are currently in the state where they are available for the suppliers. But the exact definition of active is not clear from the schema or query because we have provided some kind of schema, but like not the fully one. So clarification needed is that what do you mean by active RFPs? Do you mean RFP with the status of published or are RFP that are currently open or not closed or cancelled? So my answer to LLM is published but not deleted. So I'm giving this like, so the active RFP means that are published and not deleted. Now it will generate SQL. And this is the correct one, right? The SQL is valid. It will return 3 rows and this is the correct one. Like it has, as you can see, it has set the published and not deleted. Query 2, list all the users. So list all the users, it analyzes the query and find out that the query is not ambiguous. So it doesn't ask for any, follow-up questions regarding this. It generated the SQL and that's it. Because it is a simple query. And if it is not ambiguous, then we don't have to provide more context to the LLM. Third is show me the best suppliers. So here is the problem. Like what criteria we define as the best suppliers? So I think this is what Kushagra was asking. Like we have to define like what do we mean by best suppliers here? So I am saying the best supplier means most awarded responses. I want to, for me, like this is personal, right? For me, the best supplier is the one who has awarded the most responses by the buyers. So basically we are just solving this ambiguous query. So I think Kushagra, this will answer your doubt, right? So now it is generated the valid SQL and it returns row 1. This is the most awarded. And our total award is only 1 because the data is the main, but you can see my point, right? This is even if we have given this with providing the schema description, with providing the few short examples, still there's some kind of point like it will have this kind of query that will be have some kind of problem. Like you are asking to the LLM, give me the best suppliers, and he doesn't know what is the best means here. So it asks for a clarification, like the best supplier means the most awarded response. Like for me, actually, so this is personal. Like for someone, the best supplier could mean like highest rated ones, something along that line. I don't know, but for me, I want to get the suppliers that are most rewarded. And now the query is good. It has actually given us the correct one. Fourth, count RFPs by status. As you can see, it is very simple query. It is not ambiguous. So the judgment here is that it is ambiguous? No, false. It is not ambiguous. And then it generated the SQL. And this is the correct SQL, right? That we have 3 published RFPs, 1 awarded, 1 draft. And actually there are 2 more in rows, but we are only showing 5, like only showing 3 here. Okay, this is interesting. So show recent proposals. So we don't know what recent means, right? Recent is ambiguous. Recent can be mean show me, last 1 week, or show me only for this day only. So we don't know what recent means. So here I'm providing the context to the LLM that the recent for me means show me the last 30 days. So it is generating SQL now. And row return is 0 because we don't have any, RFPs that are basically submitted in last 30 days. This is correct. So the agent patterns. Instead of, having this user, LLM, SQL, and hope it is right, we are actually solving the ambiguity part here. We are actually saying that is this ambiguous? Is this ambiguous? If it is, then we are asking for the clarification. And if that still is still ambiguous, that we ask for more clarifications. But it is a simple. So the extra LLM can detect the ambiguity, and it costs something, right? And like never continue. Like the motto of this agent is that you don't have to be like never confidently wrong, either right or ask for help. That is the motto of this. And I think the alternative version for this, like if you know some kind of like repeated queries, if you know, guys, please check monitoring chat channel. Alerts are happening.
Kunal, I'm making a fix. You don't worry about it, please. You
Okay,
continue.
sure. Okay, so this is the alternative. So where we know the exact repeated queries, we can also use tools, right? Like these are predictable and these are more accurate and are built upfront. So that is the con for it. And they don't handle ad hoc queries. And obviously, to build these, it takes some time. But this is actually a good one for someone who has, have a limited schema and knows that these are the only questions that I'm going to answer. So that is when tool composition happens, like actually helps. So this is my like basically I'm trying to give a solution to it. But yeah, summary is this. Now I'm open for questions. Guys, shoot me. I think Kaushik might have some questions to ask. Yeah. Anyone? Any questions?
Yeah, so a couple of questions. First of all, I think this gives a very good stepping stone for our one of the key part, right, in the architecture. So
Yes.
I think a lot of question I had before the weekend, now it's clear. So thank you,
Yeah.
Kunal.
Thank you,
Yes.
Kaushik.
And I understand why you wanted to pause. Yeah, because you didn't publish the structure of your presentation. I didn't know that these are coming on our way. Otherwise I would have shut up.
Okay.
But either way,
Okay.
now I understand majority of my questions are answered. So one key question. So I'm now thinking how this fits into the our model. So
Yes.
the first question is that I know you have written some code, Python code, but are you essentially calling a OpenAI or Anthropic API, or you are everything is like from the library that you imported in your Python code?
Uh, Actually, your your question is ambiguous, Kaushik. Can you please give me more context? What I understand from your question is that you might asking me that we are making LLM queries for every SQL or not, right?
Yes.
Or these are just I've written like these examples,
Right.
like by like hard coded ones, right?
Yeah. So like skip the
So
toolchain part, but your
Yeah.
SQL to text generation process.
Yeah.
To do that, right?
Yeah.
Not the tool composition. To do that, you have shown that you have written some Python code. First you said 10 lines, later I don't know how many lines. But my question is the LLM API is involved in this generation process?
Yes. It is LLM API is involved. The every answer that you have seen, right? The every SQL that is generated is on the go. It is happening on the real time. That is why sometimes even with my failures one, it is some kind it is sometime giving me some kind of correct answer, like not maybe like 100% of correct answer, but sometime it understood that active means publish, right? But these
Sure.
are ambiguous ones. So
Okay.
everything that is generated, these are the SQL generated that are generated on the fly, that are generated in the real time, and I'm
Got it.
using the cloud model
Yeah.
Haiku. Okay.
Sure. Got it. Thanks. So the follow-up question is, uh, let's say in our structure, like one of the theme we would take is that the text to SQL process will not ask any clarifying questions. The
Yeah.
clarifying question has to be asked by the planner. So,
Yes.
so that means whatever planner does, essentially, still the quality of the semantic query could be low, and the text to SQL process may not do well. So, is there any way to get some confidence score out of the response? Like in the response, maybe a SQL is coming, but also some kind of statement which will say,
Confidence score. Okay.
low, yeah, so low
Okay.
confidence, and these are the things not clear or something. Can you get something out of that?
Yeah. I think that is a correct approach here. Like I think that we can ask to LLM to generate an SQL query and also give the confidence score based on the SQL query that it has generated.
Yes,
And that way
and
we can
also,
provide it to the to the end user, and it can guess, okay, so that confidence might be low. And either way we can you know even the planner is asking the clarifying questions. If we have that confidence score, we might we might use that internally as well, right? We can we might have like some kind of loop or some kind of chain that if the confidence score is so low, then give this query to the planner to ask more clarify questions, maybe something like that. I don't know, like
yes.
yeah.
That's essentially the idea, that when we are using
Yeah.
reflector,
Yeah.
reflector, can decide still the answer quality is good or whatnot. But if you're going for replanning, then
Yeah.
this can be fed to the planner for doing the better job. So that's one thing,
Yes.
or also for training, right? Like offline training.
Yes.
So that's one part. Yeah. So another, like, 2 points. One is that I think one of the next thing we can look for, categorizing the questions based on basic SQL operations, like the questions that essentially generate a SQL which needs basic SQL operations, and different kind of joins, left join, right join,
Yeah.
and outer join, that kind of questions, and inner joins. So that kind of category, and any other advanced SQL technique, right? So these are
Yes.
the, like, 3-4 category questions we should find the success rate. That way we would
Yes.
know. I'm not saying immediately we need to do, but like I see this is
Yeah.
one of
I think
the future
I yeah. Thanks for Kaushik. I have gotten the Carolia's database from Panos. I might be doing some kind of experiment on that database, and do you know how much it is giving us the correct answer for every query. So I think that is how we can
yeah, go for category. Like for each category, what is the accuracy, right?
yeah,
Each
what is the
category.
accuracy? Yeah,
Yes.
that
And
is
the other,
that is good. Right.
yes, the other point is that the token budget. So of course I could see that when you have a few shot example and description, schema description, the accuracy goes close to 80%, right?
Yeah,
So the question is now that, can you reduce the few shot example size,
yeah,
or can we use, like, I think schema has to be there, but future example size, can we reduce it very small size, maybe only one or two example which kind of embodies all different varieties in
okay.
ambiguity that can come
Maybe
up,
like
that,
a one basically like a one big query
yes,
that have a lot of complexity and ambiguity
yes,
to actually give the context. Yeah, that could be right.
yes.
Good,
So that kind of little bit of, also you can look that each
yeah,
category, what are the different variations of schema description and few shot, and whether with less token budget, we can achieve, or keep the same accuracy rate. Yeah, that's all
Yes,
from my
yes.
side. Thank you.
Yeah. Thank you, Kaushik. Thank you so much. So, Kaushik, I got your point. I think I have to look more into it. And yeah, Kushagra,
Yeah,
you want
just to add to what Kaushik was pointing out, maybe we can have like some, generic queries that are basically more focused on the structure of the SQL, and there might be some like peculiarities to this particular database or something, which you can store in some kind of vector DB, and based on the query that you are getting, like the actual runtime query you are getting, you retrieve some examples from that, and actually try to answer the queries so that you have some query relevant context, and you have some generic context based on all of the previous queries that you have, right? Something like that I was thinking.
Yeah, okay. Got your point, Kaushik. As I said that this is just the starting point. It has given me like a lot of things to, look forward to. Even for that, we have two things that I'm actually looking. Let me share my screen again. So the two things that I was actually looking is these two, like Vana AI and Ren AI. So Vana AI is basically, it is provide you like more of the systematic thing. Okay, let me show you. Let me show you Vana AI. Okay, let me show the Vana AI and Ren AI offline. But these two, if like these two are different things. So one is RAG and one is semantic layer. Okay, so this is RAG, one AI is RAG, and Ren AI is semantic layer. So I will provide you more context about these two tools as well. But these are also, solve some kind of problems for us. Yeah. So if you don't have any questions, then we can, drop this score. Yeah. Thank you guys. Thank you for joining.
Thank you,
Thank
Kunal.
you,
Thank
man.
you.
Well,
Yeah. Thanks.
bye, guys.
Thanks, guys. Bye. Thanks. Bye.